The given curve is revolved about the y-axis. Determine the area of the resulting surface. Right. Now, it's very important to read between the lines and to understand the formula you need to use. So obviously here we're looking at the area of the resulting surface. And so now we are actually given this, so we're going to be actually dealing with surfaces. Now you have been given x equals 2 times the square root of 4 minus y. Okay, dealing with the surface, you can be able to get what we want here. You can be able to get, for example, exactly your dy, dx dy. Okay, what is dx dy? It's 2 here, and therefore, obviously, it's 1/2 that we get, and then 4 minus y. The 1/2 you subtract, you get minus 1/2. The derivative of the interior becomes exactly a -1. Okay, obviously, you see, you are spoiled for choice. You decide to use dx dy. If there's a problem, then we're going to change everything and make it, for instance, dy dx. Okay, so now let's see how far we get with this. So which means that dx dy is equal to, now 2 times 1/2 is actually -1. Then we have -1 over the square root of 4 minus y, like this. That is the derivative. Okay, right. We want the area of the surface. So now it is the area of the surface of revolution. And we know very well that the area of the surface of revolution is given by, like we saw, it was actually given by this particular expression there. And this is exactly the expression we have. So now it was 2 pi. Right, so because this one x is the subject, so it becomes the integral, for instance, from c to d of, right, from c to d of 2 pi x. Next, the square root of 1 plus dx dy squared dy. The integral. Right, so now obviously dy, then the y is from 0 to 15/4. And then you have 2 pi x. What is x? X is this here. X is 2 the square root of 4 minus y. 1 plus the dx dy is -1 divided by the square root of 4 minus y squared dy. Okay, we continue. Now, a careful look at this reveals something interesting. Therefore, the area of the surface is 0 to 15/4. Yeah. So the 2 pi times 2 will give us, for example, a 4 pi. Right, it will give us exactly 4 pi, the square root of 4 minus y. Under the radical sign, we have 1 plus 1 divided by the 4 minus y. Okay, this is the area of the surface, right? But with the dx dy, because we've been given x, right? And then now it is that here, and you have exactly a dy. Let us continue and deal with this. So finding the area of the surface is the integral from 0 to 15/4. And then 2 pi, so we said it's going to be exactly 4 pi. Right, so it's going to be exactly 4 pi the square root of 4 minus y. Okay, right, 4 pi the square root of 4 minus y. Then we have the square root of 1 plus the square root of 1 plus 1 over 4 minus y dy. The integral from 0 to 15/4, 4 pi the square root of 4 minus y. You pull out the square root, you pull out 1 over this. So 1 over that will be 1 over the square root of 4 minus y. Then you have the square root of 4 minus y plus 1. The dy. Which means the integral from 0 to 15 out of 4. This one cancels, giving us 4 pi, the square root of 4 plus 1, it becomes a 5. So now, we have this and we just need to find the integral of this. So we can be able to easily, quickly get the integral of this. So you let u be, for instance, 5 minus y. Like that. Du becomes minus dy. Or you can then say minus du equals dy. So that we have the integral. So from 0 to 15 out of 4. Right, so we have 4 pi u to the 1/2. Then what is dy? It is minus du. Okay, good. And then now we come here. Okay, we need to change the limits of integration. Because we have dy, then we must change the new variable u. Okay, let us change those quickly. Yeah, whenever y is 0, you put a 0 here, it's going to be 5 minus 0, giving us 5. So it's going to be 5. Okay?
Hello?
Yes, please.
Yes, may I ask?
Yes.
Yes. Espera. Yung matin. Ang kumo. Zonke kusho. Uzayiklasi mo? Listen. Ngiyacabanga ngiyiwe ingeke. Ngabe athemba. Why? Why say para mas kamu athemba?
Right. And then if you substitute the y equals 50.
Sorry, hello?
Yes, yes, please.
If I got lost at the part where you multiplied by the 1 over square root of 4 minus 1.
By 1 over the square root here.
Yes.
Okay, right. So we put out the common factor because you have under the square root 1 over 4 minus y. So one way to do that is to take out to get rid of the fractions, you need to take out the 1 over 4 minus y. But when you take out 1 over 4 minus y, in the place of the 1 here, you're going to have 4 minus y plus 1. Because when you multiply by the 1 over 4 minus y with the square root, you multiply this with that, is the 4 minus y is going to cancel because this was a square root, this is a square root. So when you multiply this by that, the 4 minus y is going to cancel, giving us 1. And then you also have the 1 over 4 minus y times 1, which is 1 over 4 minus y. So indeed, this is equal to that. Or you can take the LCD, lowest common denominator, under the square root. If you take the lowest common denominator, you like cross-multiplying the things under the square root so that the 4 minus y times 1 is going to be 4 minus y plus 1. Then you have the 4 minus y under the square root. So that in the end, then you'd have the 1 over 4 minus y that is going to appear. Okay, but by good luck, then what we are able to see is therefore that this one is going to cancel this. So that it gives us 4 pi with the 4 plus 1 giving us a 5. Now, when you get to this point, our upper limit of integration here is 15 out of 4. You put it in the place of y. You want to change the limit of integration. We want to integrate now, But we can't just integrate this straight away. We need to use the u substitution. So we need to let u be 5 minus y. Then we actually get du dy, which is minus, obviously, du is minus dy. Then also minus du is dy. So we make dy the subject, okay? But now, the limits of integration, y is 0 here. So when you put y equal to 0 here, you'd have 5 minus 0. 5 minus 0 is a 5. So we have u equals 5. There it is. We've put a 5 there. But the upper limit of integration is 15 minus 4. In the place of y, because it's dy, so you have 15 out of 4. In the place of y, 15 out of 4. Then if you have 5 minus 15 out of 4, what do you get? 5 minus 15 out of 4. So you can do 5 minus 15 out of 4. You cross multiply. 4 by 5. 4 by 5. It's 20 minus 15. What is 20 minus 15? Right, it's actually exactly 5 out of 4, like this. Okay? It's 5 out of 4 like that. Okay, let's check this. Now, yeah, everything is okay. So we have the area of the surface. So you have the minus 4 pi that is going to sort of come out of this. It's a common factor. The minus 4 pi is going to be a common factor. Then we have the integral from 5 to 5 out of 4 u to the power 1/2 du. So we continue. So we continue. And then now you integrate, this is 2 out of 3 u to the power 3 out of 2. The integral of 5 out of 4. All right, so we have this one. The area of the surface is minus 4 pi, and then you have 2 out of 3 u to the power 3 out of 2. 2 out of 3 u to the power 3 out of 2, then you integrate. You integrate from 5 to 5 over 4. From 5 to 5 out of 4. Okay, now let's just deal with this. So what exactly do we get out of this? Right, so you have the 2 with a minus 4, which will give you exactly minus 8 pi out of 3. And then in the place of the y, in the place of the u, you put 5 out of 4, but it's raised to the power 3 out of 2 minus 5 to the power 3 out of 2, like this. So that the area of the surface is minus 8 pi out of 3. And then you have the top. What is the top? The top is 5 to the power 3 out of 2. The 3 out of 2, 3 out of 2 comes in many instances in these questions. So the 3 out of 2 is 1.5. Well, yeah, 1.5. So it means that it's 5 to the power 1 and then 5 to the power half. 5 to the power 1 and then 5 to the power half. 5 to the power 1 and then 5 to the power half. Okay, we check this one. Okay, this is this one. So in the denominator, you have 4. 4 is the same as 2 squared. 2 squared. The square is going to cancel these 2, giving us 2 to the power 3. Minus this one here, it's going to be 5 to the power 3 out of 2. Yeah. 5 to the power 3 out of 2 is 5 times 5, because the 3 out of 2 is 1 plus a half. So you have minus 8 pi out of 3. Then you have 5, the square root of 5, divided by 8 minus 5, the square root of 5. Okay, that's what we're getting. So what is this? Right, this becomes the area of the surface. Right, you get exactly minus 8 pi out of 3. Then here you cross multiply. Right, the 8 is going to multiply this because this one is denominator 1. So you just cross multiply. The 8 goes there. The 1 multiplies there. So you'd have the 5, the square root of 5, and then 8 by 5, 40. Minus 40, the square root of 5. Okay. Okay, 5 minus 40 is minus 35. Minus 35, the square root of 5 out of 8. Like this. Let us check if we're not getting exactly the same answer. It's like we are close to the answer. So we can see that 8 cancels here. And then you have negative times negative, which is a positive. So, which means that we have exactly what? We have exactly 35 pi the square root of 5. Right, we have exactly 35 pi the square root of 5. And then you have 35 pi the square root of 5 divided by 3. Divided by 3. 35 pi the square root of 5 divided by 3. So it's exactly the answer that is there. Any question? And obviously this thing is area, so it is in square units. Area is in square units. Okay, so we actually now need to recap on where we started. We started in this case with, we had to find the given curve is revolved about the y-axis. So because it's revolved about the y-axis, we're going to use the formula with dy. So which means that we're going to use the formula for the area of the surface because we need to find the area of the resulting surface from c to d to pi x, the square root of 1 plus dx dy squared dy. So that at this point, you actually find the dx dy, which is minus 1 over this. Remember, you will use the chain rule whenever you have obviously the square root of a lot of things like the 4 minus y, and we got the derivative to be that. In the place of the dx dy, we put the minus 1 over the square root, and we squared it, getting this. But the problem was with a fraction inside the square root, so we had the 1 over 4 minus y. And therefore we had to do likewise. Okay, whenever we had the 4 minus y, as said, there are many ways to do it. One of the ways is to take the LCD. What is the LCD? The LCD is like to cross multiply these things inside here because this one is over denominator 1. So which means that you can cross multiply and write what? And write 4 minus y here and then write the 4 minus y, you divide by 1, it becomes 4 minus y times 1, which is 4 minus y plus 1. In which case, therefore, it would be a way of dealing with this. And then you take the square root of this. When you take the square root of this, then you'd have the square root of, right, you'd have the square root of the 4 minus y in the denominator. Then you have the square root of 4 minus y plus 1. And then now the square root of 4 minus y cancels out, giving us exactly 4 pi. Then you have the square root of 4 plus 1, which is 5 minus y dy. And then you just have to integrate this one now. But to integrate this one, you just let u be the 5 minus y under the square root, and then we are able to get the integral. And we're able to get the answer, because the answer we got is 35 pi the square root of 5 out of 3. Okay, we can try to do 9b. Let's do 9b now. 9b is easy because already we know y is the subject of the equation and the x limits of integration are there, and we can be able to find the area of the surface. So, which means that to find the area of the surface, we're going to use the dy dx formula. Our y is already x squared out of 2 plus 1/2. dy dx, which is 2x out of 2. And 2x out of 2 is actually exactly x. So that 1 plus dy dx squared, which is 1 plus x squared. So the area of the surface is the integral from a to b. That's the one you're going to use. 2 pi y. The square root of, or 2 pi f of x. The square root of 1 plus dy dx, or f primed of x squared dx. The area of the surface, now you integrate. The x is from 0 to 1. 2 pi. Y or f of x. What is y? Y is all these here. So in the place of y, you put x squared out of 2 plus 1/2. The square root of 1 plus, what is this? Okay, you already know. Because the dy dx, or the 1 plus dy dx squared is 1 plus x squared. Like this, then it is dx that you have. Right. So we have this precisely. And so what then can we be able to achieve out of this? Obviously, you look at this and reason and think of it very, very carefully. Now, you need to look and think, but then come to realize that at this point, whatever you have is exactly what you have been given. And so what will the integral of this be exactly? Okay, so you need to obviously evaluate this integral and you need to think about it. And to think about it, what then do you do? You need to remember that at this point, you have the following, okay? You have exactly the following. You have precisely the following. And there's something I want to show. Right. You have these two formulas. So now here, obviously, to get the surface areas, right. So this result provides both a definition and formula for computing the surface areas. Where convenient, the surface area is a to b 2 pi y, the square root of 1 plus dy dx squared dx. Please memorize the formula for the surface area of the 2 pi y whenever you have dx here. 2 pi x whenever you have a dy there. Okay, we continue. We continue. So you have this exactly right now, and you need to do this one. Right, so you need to think here, because now how can you perform this integral here? Right, so you can see there is a 1/2 here that is coming up. Okay, there is a 1/2 that is coming up. I mean, there are many ways to do these questions, but there's clearly a 1/2. So you can write it as the integral from 0 to 1, 2 pi. Out of 2, then you have x squared plus 1. Okay, then you have the square root of that. The square root of x squared, you can write it as x squared plus 1 to 1/2 dx. Okay, so now these things have the same base. Because if you let u to be this, the 2x is not going to cancel with this. So you are brainstorming on how to integrate this, but 2 pi over pi becomes just pi. Then you have x squared plus 1, then it is raised to 3 out of 2 dx. Right. And you need to find this integral here. So when you have the integral of the from 0 to 1 of pi x squared plus 1, 3 out of 2 dx. Pi x squared plus 1, 3 over 2 dx. You need to let x be equal to the tan of theta. Let x be the tan of theta. Right, so that in the end, because now to integrate x squared plus 1, you need to use tan theta. It's a trigonometric substitution, right? So that now dx becomes what? Dx becomes the derivative of the tan becomes the secant squared of theta d theta. And then now you need to change your limits of integration. You are having an x limits of integration. You need to change to the theta limits of integration. Okay, so you change from x limits of integration to theta limits of integration. X is from 0 to 1. Whenever x is 0, you put it here, and then you have arctan 0, and then arctan 0 becomes 0. You put x equal to 1, so there is tan that. 0 equals tan theta. So arctan 1 is pi over 4. So that this one here, you're going to now be integrating from 0 to pi over 4 radians. Right, and then you have pi, and then here you'd have the x squared plus 1. What is the x squared plus 1? The x squared plus 1 is the same as what? Is the same as the tan squared theta plus 1. Then what is dx? Dx is sec squared theta d theta. Okay, the power is 3 out of 2. And then you integrate right now from 0 to pi over 4 radians. Pi, right, the tan squared plus 1 is the secant squared. Theta to the power 3 out of 2 secant squared theta d theta. Then you come to this, which is exactly the integral from 0 to pi over 4. The square cancels the square, giving us, sec cubed. Pi sec cubed theta, but there's also sec squared theta d theta. So this gives us the integral from 0 to pi over 4 radians pi to the secant to the power 5 of theta d theta, like this. Right, what is the integral of the sec to the power 5? Right, use the reduction formula we learned for the secant, but you can just use integration by parts as well. Right, so let's check this out. Because whenever now you are faced with this particular integral, but I'm just going to be very direct about it. You have to give the result. Right, so now whenever you have the integral of this, of the sec to the 5th power, of the sec to the 5th power. Okay. What we know then is that the integral of this, the sec to the 5th power, you're going to have pi outside. Then you're going to have 1/4 the sec to the 4th power x, the sine of x, plus 3 out of 8 sec x tan x. 3 out of 8. Yeah. Plus 3 out of 8. Just remove these things here. Okay, by using integration by parts, we did it last time when we're doing the 142 module, finding the integral of the sec to the power 5. So it becomes 3 over 8, the ln of 10x, or rather 10 theta. Okay, we're writing x here, it should be theta. Should be theta. So it's sec to the power 4 of theta. And then it is sine theta. And then it is theta, theta. This one is theta, sec theta. You integrate from 0 to pi over 4. You integrate from 0 to pi out of 4. Okay? So now, if you substitute everything here, let us substitute straight away. Right, so it would be that this surface area is given by, if you substitute and you put the pi over 4 here, their secant of pi over 4 is the same as 1 over cosine pi over 4, which is 1 over the square root of 2. And then if you raise it to the power 4, it's going to be pi, then 1 over 4. If you raise the square root of 2 to the power 4, what do you get? If you square it, it becomes 2 times 2, which becomes exactly a 4. So this one is going to become exactly a 4. The sine of pi over 4, sine of 45 degrees, it's going to be 1 over the square root of 2. We're just substituting. So it's going to be 1 over the square root of 2 from the special triangles from school. Right, and then plus 3 out of 8. Then here you have the secant of pi over 4, which is the square root of 2. Which is exactly the square root of 2. The secant of pi over 4 is exactly the square root of 2 because it's 1 over cosine. 1 over cosine of the pi over 4. The tan of pi over 4 is a 1. And then now this is exactly 3 out of 8, the ln. The tan of pi over 4 is 1. The secant of pi over 4 is the square root of 2. Okay, so you put the 0, this is going to be 0, 0, and yeah. And then it's going to be minus. It's going to be minus. Okay, because if you put the 0 here, sine 0 is 0, tan 0 is 0, everything is going to be 0 here. And then you come to this, and then you have tan 0, which is 0. The secant of 0 is 1. Ln 1 is 0. So that's everything is going to be 0. So we're only left with these things. Let us check this out. So the area of the surface, then it's pi outside. Then the 4 and the 4 cancel out, giving us 1 over the square root of 2. And then this one here becomes exactly 3 out of 8. The square root of 2. And then it is 3 out of 8. The ln of 1 plus the square root of 2. Like that. Okay, let's check what we got here. Let us check what we got. Okay, let us analyze these together. Okay, just 1 second. I need to check if there's no just typo because the answer is a little bit different from what has been given. But let us pause to reason. Let us pause to check this out. So we have the integral from 0 to 1 of pi. Okay, I'm just checking this, please, to see if we need to make a small change somewhere in the numbers. Plus 1, you close, and this to the power 3 out of 2. All right, so let us check this out and see what we got. Okay, and see what we got exactly. Right. Let's check. Let's check. Okay. You see, our answer looks very correct from my position. So it'll be very interesting to see, therefore, that they right. Okay, there might be a couple of ways to do it, of course. Need to check this out. There might be a couple of ways to do this particular question, but obviously our result looks very correct. There are two ways to do it, of course. So you can do it like this, or you can use the dx dy formula, because we use the dy dx formula. Okay, I'm looking at the fact that our answer looks long, but theirs looks short. But even if I use a computer to do the calculation, because I can use a computer to just do this integral straight away, but we are getting this answer here from this integral, meaning indeed you go through that substitution there, and then you get the lead of 1 plus the square root of 2 either way, and then you have the result on this side. You'd have the result on the side. So our answer is very correct. Very, very correct. Okay, but I can see that theirs is like short like this. It's not something that you can think about and see. Yeah, but it is yeah, there's okay, there are two ways to do it, of course, obviously. I mean, if you get a situation like this where the answer is correct, and now you can see it's long and theirs is short, you can also do the other thing. The other way is to make x a subject and then do the dx dy formula. Use the other formula, because we use the dy dx and then we got that answer. And then we can use also dx dy to get the answer. And then actually sort of begin to sort of compare the two answers there. Okay, but yeah, and as far as I can think of this is fine. Okay, let's move to number 10 to avoid wasting time. Show that the surface area of a sphere of radius r is 4 pi r cubed by revolving the semicircle about the x-axis. So obviously now, if you look at the semicircle revolved about the x-axis, okay, the semicircle y is positive. So the semicircle is going to be here. Y is the square root of r squared minus x squared, and then this is y and then x. So that then in the end, if you want to find the surface area of a sphere, so you're going to use the formula again, the integral, because this one is already y equals. So if y is equal to r squared minus x squared, then you raise it to the power 1/2. So that you have dy dx is equal to, okay, the derivative of this is 1/2 r squared minus x squared, and then you subtract 1 from the half, getting minus 1/2. The derivative of the inside by the chain rule, the r squared has 0 derivative, the minus x squared has minus 2x derivative. Right, meaning you're going to have the integral from a to b 2 pi y, the square root of 1 plus. So this becomes exactly dy dx. So you square this and it becomes exactly a dx there, like so. Right, meaning that at this point you perform your integration. For the x, the circle will run therefore from minus r to r. 2 pi y. What is y? Y is exactly this. So it is exactly the square root of r squared minus x squared, which is 1 plus the dy dx then is minus x divided by the square root of r squared minus x squared. And then you square this. Okay, yeah. So now we have dx. Okay, so which means that the area of the surface from minus r to r, it's 2 pi the square root of r squared minus that. We're using this formula. Then we have 1 plus, you square this one, it's actually x squared, r squared minus x squared. dx. So that now S equals the integral from minus R to R 2 pi the square root of R squared minus that, then the square root of 1 plus x squared over R squared minus x squared dx. Take a look. It's 1 plus x squared over that. So this becomes sort of the surface area. Okay. So now we can do the same. We always do the same. So when you take out the thing that is the same as the square root of this one, yeah, you take out 1 over. 1 over R squared minus x squared. Okay, this one. So when you take out 1 over, like we always do, you in the place of the 1, you're going to just have the R squared minus x squared. Then this x squared, this one, is just going to remain. You have that. Okay? So we're in business now because this works out beautifully. You know, the x squared minus x squared is a 0. And we therefore get that also this one is going to cancel this, giving us the integral of minus R to R. Then you have 2 pi, the square root of the R squared, which is 2 pi R, the integral of this, dx. 2 pi R, and then we have x, the integral from minus R to R, which is 2 pi R, then we have R plus R, R minus, okay, R minus, then minus R. And then now you have 2 pi, okay, you're getting the surface area is 2 pi, then you have R plus R, because negative times negative is positive. 2 pi, okay, there's 2 pi R, remember? 2 pi R here, 2 pi R there. So let us write properly. So there is a 2 pi R that is like outside, you know, 2 pi R. So 2 pi R, but there is R plus R. R plus R. All right. And then 2R. 2 times 2 is 4 pi R squared. Good. So we got 4 pi R squared. Any question about this? But this would give us the actual surface area of a sphere of radius R by revolving the semicircle. We started with the semicircle. By revolving this semicircle about the x-axis. So we're looking for the surface area. In the surface area quest, in the quest for the surface area, we used the dy dx formula because it was already y equals something. So it was easier to use that one, but yeah, you can also use the other formulas. Like you can also use dx dy, but yeah, the y, when y is the subject, it's easier to use dy dx. Right, the figure below shows a spherical cap of height h cut from a sphere of radius r. So you cut a little bit there from this sphere. This sphere is of radius r, but you cut the top. Show that the surface area of the cap is 2 pi rh. The hint is that revolve the portion of the circle x squared plus y squared equals r squared in the first quadrant from y equals r minus h to y minus r about the x-axis. Right. To y equals r about the y-axis. So it is the same thing. And let us see what we need to do there. Right. So to do this number 10, you would have the following. Right. So now you need to deal with this. But the figure below shows a spherical cap of height h. Right. cut from the surface of a sphere. So now what will the remaining portion be here? The remaining portion will be the radius minus h, because the distance from the center to the circumference of the sphere is the radius. But it's going to be the radius minus h, and that is going to be the y. So you're going to have y equals radius minus h. But also we have y equals r. So revolve the portion. Hint, revolve the portion of the circle x squared plus y squared r squared in the first quadrant, right? From r to that to r equals that, about the y-axis. Meaning, therefore, the area of the surface, right? So a portion of the circle in the first quadrant, right? So to revolve a portion of the circle in the first quadrant, so you're going to have, for example, a portion of the circle in the first quadrant is going to be like this. Right, and you actually integrate it from y equals r minus h to that. So now, these are the y limits of integration. So y limits of integration means that you're going to have a dy, and with the dy, we have 2 pi x. The square root of 1 plus dx dy. You square it, which is 2 pi. Okay, so if you integrate this in the first quadrant from y equals r minus h to y equals r, but yeah, you revolve this about the y-axis. So you have this. So which means that you have r minus h, r 2 pi. Then you need to substitute everything. What is your x here? The portion of this in the first quadrant, you need to make y the subject from the equation of the circle. But from the equation of the circle in the first quadrant, you're going to have r squared minus x squared square root for the y. And then you can also make x, which is what we want. So, but also x is positive there. So x is the y squared. So you have 2 pi. We have 2 pi r squared minus y squared. That is the x. Okay, and then you need dx dy. So the dx dy you can get from the differentiation. Right, so which means that out of this, then you can find the dx dy, which is 1/2 r squared y squared. Then you have minus 1/2, the derivative is minus 2y. 1 plus this cancels, it's minus y divided by the square root of r squared minus y squared. This squared dy. So that now you have this one, which is from r minus h to that. Then you have 2 pi. Right. Right. So, okay, let's continue. Okay, so this one is going to be r squared minus y squared. You square this one under the square root, it becomes 1 plus y squared over r squared minus y squared. dy. We have area. From r minus h to r, 2 pi. 2 pi r squared minus y squared. And then you have this one here. So you do the same thing. You factor out the 1 over the denominator. So it becomes 1 divided by the square root of r squared minus y squared. Then here you have the square root. So this r squared minus y squared is going to appear. Then we have a y squared, and then you have a dy. That is what you're getting. So that this cancels. This cancels. R minus h r to pi the square root of the r squared dy. R minus h r 2 pi r. Okay, 2 pi r, then you have dy. So this is 2 pi r. The integral of the y is just y. Then you're integrating from r minus h to r, which is 2 pi r. Then you substitute r minus h. 2 pi r, we have r minus r plus h. R minus r cancels, giving us 2 pi r h. There it is, 2 pi r h. Then we have found the answer. Any question about the question 10b? We're to revolve a portion of the circle, which is x squared plus y squared, in the first quadrant from y equals r r minus h. And we said already, you see the r minus h is from the fact that at this point here, the whole radius, the distance from here to there is the radius. So from the radius, you remove a small portion. So you integrate, therefore, from r minus h to y equals r about the x-axis, the y-axis, and then you get the answer. Okay, they might not even give you the hint in the exam. You don't know. Okay, but yeah. But now let's look at where we started with this. With the 10b, we started here and we used the formula because we advised to revolve these about the y-axis. So we used the 2 pi x, the integral, the square root of 1 plus dx dy. Obviously from y equals r minus h to y equals r, and then we got the answer. Any question on this? Any question on this? Okay, we move on to the next question. Okay, you advise that we do from 1 to 10, which is what we have done. Let me see. You advise that we do from 1 to 10. Okay, which is what we have done. So now we need to do the other one. We need to do the other one. Okay, you advise that we do from 9 to, okay, we do up to 10. Right, tat 2, from 6 to 10, which we have done. Then we do tat number 1. Right, tat number 1, figure 2. EF3 that. Okay, okay, let's see. Okay, let's see now. We went up to number 10, so we have all the tat questions here. Let's check what we got. We're moving back to tat 1. Okay, we did the arc lengths. We did all of them. We did all the arc lengths calculations. And then, let's see. Yeah, we did the arc length. And then now we're going back. Then we did tat 1. Okay, so let's check. Okay, we're going to tat 1, please. Okay, let's check the tat 1. Okay, here is tat 1. Okay, here is tat 1. Right, and you advised that in tat 1, we need to focus on what? Tat 1 need to focus on figure 2. Tat 1, number 1, figure 2. Okay, which is this one. Right, in each case, find the area of the shaded region by A, integrating with respect to X, and B, integrating with respect to Y. Okay, so let us look at this one. You want to integrate here with respect to Y. So to find the area, and we need to integrate with respect to Y, would have a dy. So integrate from something to something. Okay, now this x equals y, and this x equals 1 over y squared. Okay, these are equal to each other. What are the limits of integration? What are the points of intersection? So you have, you'd have therefore that, you'd have that the points of intersection of this one would be exactly x equals x, but x here is equal to y, and then x is 1 over y squared. You cross multiply, getting y cubed is 1, and then y is the cube root of that, which is exactly a 1. Right, integrating exactly from y equals 1 to 2. Okay, y is 1 here to 2. Right, if you integrate with respect to y, what you do is you fix y and you imagine an arrow. If you fix y, y runs from 1 to 2. This arrow is going to penetrate the region through this curve here and exit through the straight line. So we're using the right minus left rule. In the right is y, the left is the curved section, which is 1 over y squared, like this. So this is going to give us the area. So that we have the integral from 1 to 2 of y u to the minus 2 dy, which is the y squared out of 2, then you have plus y to the minus 1, and then you integrate from 1 to 2. You put in the 2, which is 2 squared out of 2 plus 1 out of 2, minus 1/2 plus 1. The area is, what is 2 squared? 2 squared over 2, it's 4 over 2, which is exactly 2. And then now you have this one here. You have half minus half, which is 0. Then you have minus 1, and therefore the area is 1. So indeed, area here with respect to y becomes what? The area with respect to y is equal to 2 minus 1, which is 1 unit squared. Any question? I believe it is clear enough. So we did now chart number 1, and then we did number 1, then we did figure 2. And then we also go to the 2E and F. Okay, so you have 2E and F, then we go to 3. Let's look at 2E and F. Sketch a region enclosed by the following curves and find its area. Right, so what is the region enclosed by the following curves? Right, take a look and realize that at this point you have the following shape. Right, you have these together with that, the y and the x. So the curve y equals the modulus of x is like this. So this one is y equals the modulus of x, so the absolute value. And then this one now is the same as the following. What is this graph here? Okay, this graph resembles a very famous graph, 1 over x squared graph. The 1 over x squared graph is like this. But now, even if you put a 2 over x squared, it's going to be like that. But now, if you add a 1 like this, what effect would it have on the graph? Right, so if you add a 1 like this, it has a certain effect on the graph. For example, what would are there any x-intercepts? When y is 0, y can never be 0. When x is 0, then you can see that when x is 0, y is going to be 2. Right, so whenever x is 0, y is going to be 2. Right, so indeed, you can see a shift in the graph. Right, you can see an immediate shift in the graph, okay? Just 1 second. So that in the end, then you need to get this one right. And obviously, you are dealing with y is equal to exactly 2 over 1 plus x squared. 1 plus x squared. Right, so the kind of graph then you're going to have is going to be sort of like this now. Okay, just 1 second. Just 1 second. I'm checking this graph here. Yeah, it's going to be a graph that is sort of like this. Okay, so this is the sort of graph you're going to have. Okay, so sketch the region enclosed by the following curves and find its area. So the area is going to be this one here. Right, so let us check this out. The area. Okay, now obviously you need to find the points of intersection of this. It's easier to integrate with respect to x. So because you can fix x and you have the same curve here, the same curve there, but now if you're going to fix y, it's going to be hard because you have one curve, the green one here, you have the bottom. So we're going to actually integrate with respect to x because you just need to get the limits of integration, which are the points of intersection. So you get the points of intersection. What are the points of intersection? You have y equals the modulus of x. Y equals 2 over x squared plus 1. Okay? One plus x squared, which is x. So then the question becomes, what are these? And then you have two things. 2 over 1 plus x squared is also equal to minus x. So the question becomes, what are the points of intersection of these? What are the points of intersection of these? Okay, I'm checking those. So if you have 2 over that, then you have the x, which equals that exactly. So either way, these are going to intersect when x equals 1. Right? When x equals 1, y would be 1. When x equals minus 1, y would be 1. So that now for the x, you're going to integrate from minus 1 to 1. And then take the upper curve, which is the green one, which is 2 over 1 plus x squared, minus the lower curve, which is the modulus of x. Okay, yeah, there's a little trick here, but you can split it into 2 because of the modulus. So you can first integrate from minus 1 to 0. Then you have this. From 0 to 1. Okay, then you integrate from 0 to 1. Then you still have the upper curve, 2 over 1 plus x squared. Then you have minus the lower curve. Okay, but look, this one's going to be plus. And this one is going to be minus x dx. Because this curve here is y equals minus x, and then this one is y equals x. Right, so that the area, you have 2 arctan of 1 plus x squared. Half x squared from minus 1 to 0. Arctan x Okay, let's check this one out. So it's going to be arctan x minus 1/2 x squared. You have that. Minus 1/2 x squared from 0 to 1. Okay, let us see what you get. So we just need to calculate this one. If you substitute straight away and you plug in the x, the 0, and then it's going to be arctan 1. Okay, if you put the 0 in place of x, then it's going to be 0 squared plus 1, which is arctan 1. Arctan 1 is pi over 4. Then you put the 0 here. And then you have put the 0, then you put minus 1. Arctan 2. So now you substitute everything. And then now you have 2 arctan 1, which is pi over 4. You substitute here. And then you put the 1. You have a 1/2. Then you put 0. Arctan 0 is 0. And then everything becomes 0 there. So the question is, what is the area? This one is going to be exactly the pi over 2 here. So you have pi over 2, and this one is going to be plus pi over 2. So we're done with this, and then there's going to be minus 1/2, minus 1/2. Okay, minus 1/2, minus 1/2, but there appears to be minus. Okay. And then it's going to be minus 2 arctan 2. The pi over 2 gives us pi. Minus half is minus 1. Minus 2. Minus 2 arctan. Arctan 2. Okay. Okay, let us check this out. Let us check this out. So, I mean, we're getting this answer here. We're getting this answer. But you see, it's very close to that, but yeah, there's just pi minus 1, but the other thing is missing. So let us see what we're going to get here. Gonna have the integral from minus 1. I'm checking this out to 1, and you'd have the upper curve, which is 2 over 1 plus x squared. Then you have the lower curve, which is the absolute value of x. Absolute value of x. Right. Okay. It is only pi minus 1. Let's see what we need to check here. See what we... Here's the mistake. Oh, God. Right. So I can see the mistake. Just one sec. Right. So here is the error. Right. So now just a little error, but yeah, it's going to make things easier for us. Now that we just to make the small change. So look, in the end, you're going to have, right, if you integrate the 2 over these, it's going to be 2 times the integral of 1 over the, yeah, so it's from minus 1 So you can write like this. You have 2 the integral of 1 over 1 plus x squared dx from -1 to 0. The integral of -1 to 0x dx. The 2 the integral of 1 plus x squared dx from 0 to 1 minus the integral from 0 to 1. And then in the end, it becomes 2. This one becomes arctan. Arctan x from -1 to 0 plus 1/2 x squared from -1 to 0. And then you come to the same thing. Okay, for this one. For this one, it becomes 2 arctan x from 0 to 1, 1/2 x squared from 0 to 1. Area. So you have 2 arctan x. And this is from -1 to 0. And then we have 1/2 x squared from -1 to 0. And then you have the 2 arctan x from 0 to 1. Okay, this is a minus 1/2 x squared minus 1/2 x squared from 0 to 1. Two arctan 0, 2 arctan -1. Minus 1 squared. And then plus 2 arctan of 1 minus 2 arctan 0. Minus 1/2, 1 minus 0. Squared. Area. Arctan 0. It's 0. This negative and negative becomes a plus. The arctan of this is going to be pi over 2. And this one is going to be 0. And then this one is going to be -1. So it's going to be like minus 1/2. And then this one, it's 2. Even here, there's a 2. There's a 2. But it's a plus. Okay, let's just check these things out. So you come to this one, arctan 1, which is pi over 4 minus 0 minus 1 area. Okay, even this one is pi over 4, please. Pi over 4, so that we have pi over 2 minus half, and the area becomes a pi over 2, which is actually pi minus 1, like that, which is this. Okay, so yeah, think about it and check this out. But we found the answer to be the area, which is pi minus 1. Oh, you suggested we do 2E and F. So remember, we started with this. The small little trick here was to be able to draw the graph of the 2 over 1 plus x squared. All right. So that's the thing. You must be able to draw the graph of that. You see, there are many graphing apps that you can use, applications. I'm here to give you more information about the graphing applications so that sometimes you're much faster. But I know very well that in the exams, you can't be using apps. You know, you can't be using your cell phone to do these things. Okay, we have these tools to use and to verify our answers. And move on. We're looking at F now. We look at F now. Okay, we're continuing. Okay, y'all. Okay. So take a look at this. Now, if you think of this, let's continue and see what we got. Let's look at F now. Right, to look at F, then you need to be able to find the integral of this, the area of this, but let's have an idea of the sketch. When X is 0, Y is 7. When Y is 0, X is going to be a positive number. So this will be the graph of Y equals minus X over 5 plus 7. Then you also have this other graph here. When X equals 0, Y is exactly 3. Okay, so this one is a transformation of the absolute value graph in general. So if this is the absolute value graph, and if you subtract 1, the graph shifts 1 unit to the right. It shifts 1 unit to the right. Okay, check this out. And then you have 2, so it's going to be moved up a little bit whenever X is 0, yeah. Right, it's going to go like 2 units up. Yeah, so that we have 3 here, but it's going to be a 2 there. Something like this. Right, so you're going to have this kind of a graph, but now it's going to cut at 3. Whenever X is 0, the y-intercept is at 2 plus 1, which is 3, and then it's going to do this, and it's going to be cutting at 2. Right, so whenever X is 1, yeah, it's going to be translated that way. So you'd have the sort of graph that is appearing there. Okay, let's check this one. I don't know what is your time, your stoppage time. Please let me know, because I'll just go on and on and on. Right, so you have this, and then now, obviously, this one cuts at 7, but you'll have to find the point of intersection. Like here, at this point, we expect this to intersect whenever the there's a positive slope, which means that it is when you 2 plus positive slope, then you take the positive, right? Because this one is going to be the positive 2 plus X minus 1, like that. Okay. Minus X out of 5 plus 7. The 2 minus 1 is a 1. Minus X out of 5 plus 7. Multiply through by 7, get 7x plus 7 equals, you multiply it through by 5. That's what I mean. And if you do, it becomes exactly 5x plus 5 is equal to minus x plus 35. Right, and then you have 5x and x, you get the 6x equals 30. X is 6. So this one is going to intersect at x equals 6. And then at y equals what? So at 6, when x is 6, you put 6 minus 1, you get a 5, plus 2, it gives you a 7. Okay, at that point there. Right. Okay. Right, so this is what you have. This is what you have. All right. Let's check also this one. The 2 plus, there's also going to be the one with negative slope. So it's going to be minus x minus 1. 2 minus x minus 1 is exactly equal to minus x out of 5 plus 7. Multiply it through by 5, which is 10 minus 5x plus 5, 35, which is minus 4x. So now this is 15. And then 35 minus 15 is 20. Which means x is minus 5. So it's going to intersect at x equal to minus 5 because this thing is going to go on like this. Therefore, it's going to apparently, therefore, intersect at x equal to minus 5, but also when x is minus 5, then you put it here. Minus x out of 5 plus 7. When x is minus 5, then it's going to be 5 out of 5 plus 7. Which means y is 8. At 8, like that. So this graph is also going to go on like that. Okay, so this is the sort of graph you're going to get. So now let's continue. In continuing, we want to find the area that is shaded. Let us determine the shaded area. So it's going to be the following. Okay, let's take a look at the following. Okay, now to find the area, it's the following. Right, you need to say area. Okay, so we would examine this and check. So you can do it in 2 parts. Because now the absolute value has a positive, has a negative slope here and then a positive slope there. So you're going to integrate from minus 5 for x to whatever x is here, and x at this point, it's a 1. And then now if you integrate there for x, you imagine an arrow that sort of penetrates the region going up. Right, the upper curve becomes the straight line graph. The lower curve becomes this, the absolute value with a negative slope, which is 2 minus x minus 1. And then you do dx. You continue with the integration now from 1 to x equals 6. And the upper curve in this region, after the vertex, the upper curve is going to be the straight line. Upper curve minus the lower curve. The lower curve becomes the parabola with, it becomes the absolute value graph with the positive slope. Positive slope because the slope is positive here, and then the slope is negative there. Which means that you have 2 plus, put a round parenthesis, and then you have x plus 1, like that. Yeah. So the upper curve is going to be the straight line, then the lower curve is going to be the absolute value function, then dx, like so. Okay, take a look at this and think. Right, so the area, minus 5 to 1. So we continue. We continue. Okay, if we continue what? We get minus that. Minus x out of 5 plus 7 minus 2 plus x minus 1. Okay, multiply by negative here, and then you get that, dx. And then 1 to 6 minus x out of 5 plus 7 minus 2 minus x plus 1. Minus x plus 1. So now you need the area. Which is exactly minus 5 to 1. Right, so you have exactly 5x minus x, which is 4x over 5. Okay? 7 minus 3 is a 4. One to 6. And then this one is minus that, minus x over 5 minus x, which is minus 6x over 5. Right. And then you have 7 minus 2 plus 1. Minus 2 plus 1 is a minus 1. And then 7 minus 1 is it's a 6. Like that. Okay, check this out. The area. So this is 4 out of 5, x squared out of 2. Exactly with 4x. You integrate from minus 5 to 1. And this is minus 6 out of 5, x squared out of 2, and then 6x from 1 to 6. The area. So this is exactly 2 out of 5, x squared plus 4x from minus 5 to 1. Minus 3 out of 5, x squared plus 6x. And then you integrate from 1 to 6. The area. Okay, plugging in the 1, you would have 2 out of 5 plus 4 minus 2 out of 5 plus 4. Okay, that is when you plug in the 1 and then you substitute the minus 5 and then you square the minus 5. It becomes what? It becomes a 25. The 25, if you multiply by 2, becomes a 50 out of 5 minus 20. Plus, you have the 6 squared, which is the 36. So it's minus 3, and then with the 36 out of 5. Plus, 6 by 6 is the 36 minus 3 out of 5 plus 6. Area. Okay, let us do it this one. We can do it, use a calculator here to save a lot of time. And also to avoid a couple of errors, but normally you can do without one. You still can do just basic numbers that are being added. Open bracket. 2 out of 5 plus 4 minus like 50 out of 5 minus 20 plus. Okay, then you have minus 3 times 36. You divide by 5. You add a 36. You close the bracket. You subtract. You open the bracket. You minus 3 out of 5 plus 6. Okay. It appears that you get exactly that. Let's check this out. Okay, there might be a small error. You see, the answer is 23.4, which is close to 24. So there might be a number that we need to check, or a sign that... okay, let's just check again. Let us check again. I'm just going through the things. Yeah. I'm trying to see if there's a number that is amiss. So -1 to 5, then you have 4 to 5, then you have a 4 like that. 1 to 6, this one, yeah. Which is 5, which is 6 out of 5. 7 minus 2 is a 5 plus 1, it's a 6. Okay, so what do you have here? Yeah. So the 2 divides here, giving us 2x squared out of 5. So which means that minus 3 out of 5x squared plus 6x. So you put here minus 5 squared is a 25 times 2 is a 50 out of 5. And then you put minus 5 by 4 is a minus 20. I'm trying to go through these here, so you have to make sure we have the correct answer. And then now you put a 6. A 6 squared is a 36 out of 5. And then 6 by 6 is also 36 minus 3 out of 5. And also plus a 6. Right. Let us check what we're getting here. Okay, so we're getting that the area should be about 24. We got 23 point something. So let us see what we're going to have here. So this one is going to be out of 5, out of 5, out of 5, out of 5. How many of these? So there's going to be 2 out of 5. There's going to be this. Let's watch the signs, I think. There's going to be a 2 out of 5. Then there's going to be a minus 50. This and that. Out of 5, there's going to be a minus 90 and 18, which is minus 108 out of 5. And then this one is going to be exactly a plus 3. All these things are out of 5. Then we deal with the others that are like whole numbers. So we have the 4. We have the 4 plus 20. 4 plus 20, and then you have a 36. And then you have exactly a minus 6. So that's the area. Okay, we check this out. Okay, let us deal with the top. Okay, let us check here. Right. Trying to see what we're gonna get. So this is going to be like in the top, it's going to be 2 minus 50 minus 108. 2 minus 50 minus 108 plus 3, which is minus 153. Minus 153 divided by 5 plus 4 plus 20 plus 36 minus 6. 117 out of 5. Okay, I need to check this is still getting the same answer. Uh-huh. Okay, we're getting the same answer still. We need to do a couple of checks. Uh-huh. So now are the limits of integration the correct ones? We need to just do a couple of checks. Are the limits of integration correct? Okay, let's check here. So obviously we can see that you have this one negative slope, which is 2 minus x minus 1. It's going to be equal to the straight line, which is minus x out of 5 plus 7, which is 2 minus x plus 1, which is minus x out of 5 plus 7. So you multiply, and then this is going to be 3 minus x is minus x out of 5 plus 7. I'm checking the limits of integration. Multiply it through by 5. You get a 15 minus 5x, which is minus x plus 7. You bring it across, which is minus 4x, which is actually exactly minus 4x, which is actually then equal to minus 8, which is equal to minus 8. Let's check. 2 minus that. Yeah, so it's a minus x plus 1 minus x plus 7. So yeah, you'd have the this one in negative slope. Okay. All right. So multiply through by the 5, which is okay. Before you multiply by the 5, we added 2 plus 1, giving us a 3 minus x, which is minus x out of 5 plus 7. Multiply through by 5, so you get a 15 minus 5x minus x plus. Okay. Check this out. Right, so this is minus 15 minus 5x minus x, and then a 35. So 7 by 5 is a 35. I'm just checking the numbers and trying to verify what's happening here. So if you have this, then you bring the minus x to the other side, becomes minus 4x. Right, minus 4x is equal to 20, because the 35 minus 15 is a 20, and then the x is a minus 5. So indeed, we get a minus 5. When you get a minus 5, you put it here. You put the minus 5 here. It's going to be exactly a minus 5 over that, which is actually 1 plus 7, giving us 8. That is correct. But the other limit of integration, then it's going to be exactly y is 2 plus x minus 1. It must be equal to exactly minus x out of 5 plus 7. This means that you have exactly 1 plus x equals minus x over 5 plus 7. Multiply through by 5, which is 5 plus 5x, which is minus x plus 35. Like that, which is 6x is equal to 30. 30 divided by 6 is a 5. Uh-huh. Yeah, so that is the thing. So I think that is the error. That is the error. So you're getting that x must be 5 and not 6. getting that x must be 5 and not 6. Okay, getting therefore that x must be 5 and not 6. Once again, you're going to have this thing, getting that x must be 5 and not 6. Okay, if x is 5, then you put it here. You have 5 minus 1, which is a 4, plus 2 giving us a 6. It's giving us exactly a 6. Okay, so the limits of integration, therefore, here will change to 5. Will change to 5. 1 to 5 here, and then 1 to 5 there. Right, so it is going to change to 5 here, 5 there, 5 there, and so on and so forth. So it's going to be 5 there, 5 there, 5 there. Okay, let us check what we got. When you get to this point, then it's going to be a 5 here. Right, so it's going to be exactly a 5 here. Yeah. And then this one is also going to change to a 6 by 5. Okay, like that. Okay. So everything else is going to be the same, but you're going to be a minus 3 by 5 in out of 5 denominator. Okay, so this one is going to be 2 minus 50, and this one is going to be minus, let's see what we're getting. Okay, yeah, this one is going to be exactly a 25. If you square it, it's going to be a 25. And then minus 50 and then minus 3, which is a 75. Plus 3 out of 5. 4 plus 20 plus 30 plus 30 minus 6. So the area becomes, okay, let's use a calculator to save time, but you still can do without it. Let's just use the calculator to save time. Right, so you're gonna have, for example, 2 minus 50 minus 75 plus 3. You divide by 5. You get a minus 24. And then minus 24 plus 4 plus, it's already out. It's already the answer we got that we need. 20, then you have plus 30, and then you subtract a 6. And you're getting 24. So indeed, the area is 24 there. The area is indeed 24. So the area is indeed 24 units squared. So indeed, this is correct. Please advise on your stoppage time, because we depend on you to know when to stop. Right, so it is number 2 right now, and we did the areas. What should we do now? Because we did like 2E to F. We did 2E to F, and then we must do number 3. Find the number C positive such that the line y equals C divides the region bounded by the curves y equals x squared, y equals 4 into 2 regions with equal area. Okay, so this point, let us have a rough idea of the region we're dealing with. Right, so you have y equals x squared, which is the quadratic. y equals x squared, which is this quadratic in standard form. Y equals x squared. Y equals 4. Is this one? Y equals x squared is the parabola. Y equals 4 is a straight line. So find the number c that is a positive number such that y equals c divides the region bounded by the curves these into two equal area, into two regions with equal area. So the y equals 4, the y equals c, it's a number that is positive. So it is y equals c that sort of divides. That sort of divides the area, but the areas must be equal to each other. Okay, so a very little question. So now what you're going to do here, you're going to divide these into area 1 and then area 2. But you require that area 1 should be equal to area 2. Let us deal with this and therefore the points of intersection of this. What are the points of intersection? This is the parabola. Whenever y is c, what is x? Whenever y is c, so you have the graph y equals x squared, but y is c, which means that x is plus or minus the square root of c. So at this point, then you have a positive the square root of c. At this point, you're going to have exactly positive the square root of c, and then the c here, you have minus the square root of c in the c, which is those points. So now there you're going to deal with this as follows and see what else you need to do. Okay, to deal with this, should you integrate with respect to what? Okay, it's easier to look at things horizontally. So you're going to split into two areas and integrate with respect to y. Because if you integrate with respect to x, then there's a problem because if you imagine an arrow that goes up here, it's going to pass through the parabola and exit through the straight line, pass through the parabola, exit through the straight line. So you need horizontal observation. So you're going to therefore be able to integrate from y equals c to y equals 4. Okay, from c to 4. What is the upper curve? Right, if you integrate is right minus left. So now right is going to be exactly this one, which is x equals what? X equals plus or minus the square root of y, but now you're dealing with a positive here. So right is the square root of y minus left, which is minus the square root of y dy. And then now plus. So integrating from 1, from 4, from c to 4, and then integrate. Right now from 0 to c. From 0 to c. The upper curve is you integrate right minus left. Use the right minus left rule. Right is the square root of y, and left is minus the square root of y. dy. Right, so,
Sorry,
yes, please.
please, may I ask why are you separating the graph by the graph? Right, so when you're saying right minus left,
Yeah, when we're saying right minus left, to say why, okay, yeah, why are we subtracting? Is that correct? That's the question.
please.
Yes, we're subtracting because we actually are attempting to determine the area. So to find the area, we need to say right minus left. But obviously, I mean, I agree that here is right, and right is the positive x, and the left is negative x. So it's a square root minus minus. Minus minus. Why do we subtract? We subtract because we're trying to get the distance between two numbers. So there's an x number here and an x number there. And I mean, this principle of subtracting is actually taken from numbers on the real line. Somebody can say, what is the distance between, because that is what it is. It becomes sort of the distance between two numbers, a number here and a number there. And what can we do to find the distance between 3 and 5 on the real number line? We need to say 5 minus right minus left. 5 minus 3, 2, and 2 sort of becomes the distance between the two numbers. So it becomes the same because these are numbers on the real line. And therefore, obviously, now we then say here we have the square root, positive square root, and then the negative square root. But obviously, this one here is x is negative, because if y is x squared, we want to get x plus or minus the square root of y plus or minus the square root of x squared, which is plus or minus the square root of y equals x. Right, so we integrate therefore and find the area. So it's going to be 4 to c, then you have square root of y, 2 of the square root of y, but you can do much more than that. The square root of y is y to the 1/2 dy plus, then this is square root of y, which 0 to c to y to the 1/2 dy, area 2 to the 2 out of 3, y to the 3 out of 2, c to 4. Okay, you have the 2. If you integrate the y, it's 2, the y to the 1/2, it's 2 to the 3, 2 out of 3, then y to the 3 out of 2, integrate from 0 to c. The area becomes 2 by 2, it's a 4 out of 3, then you have 4 to the 3 out of 2 minus c to the 3 out of 2, plus 2 by 2 is 4 out of 3, then you have c to the 3 out of 2 minus 0. Right, so let us just do the simplification so we might be able to get the correct answer here. Anyhow, my point is that the two areas are equal to each other. See, so what you need to do is to equate the areas, then to add them up. Right, so you need to equate the two areas, then to add them up. So what then we have is that the two areas, so area 1 is equal to area 2, like this. Right, so then we want to solve for c, and they're saying, right, find the number c. So now at this point, what do we have here? Which is exactly, okay, which is exactly 4 out of 3, okay? Right, so want to solve for c out of this equation. We have 4 out of 3, then the 4 is 2 to the power 2. 2 cancels, giving us 2 to the power 3. 2 to the power 3 is 8, minus c to the 3 out of 2 is equal to 4 out of 3 to the c 3 out of 2. The 4 out of 3 cancels out, giving us 8c to the 3 out of 2 equals c to the 3 out of 2. 8, which is 2c to the 3 out of 2, you divide by 2, which means that c to the 3 out of 2 equals 4. Okay, so already done with this. But we just need to solve for c from that particular equation. So if c to the power 3 out of 2 is 4, then what is c? Right, then what is c exactly? Okay, then we know that c to the power 3 out of 2 is 4, which means c to the power 2 out of 3 now. Right, and which is 4 squared, 1 out of 3. And 4 squared is 16. To the 1 out of 3, 16 to the 1 out of 3, it's the cube root of 16. It is exactly the cube root of 16. So we've been able to get the answer there. Any question? So this is an example that demonstrates why we have to integrate with respect to y. Integration with respect to x would have been more difficult, but also would involve even more partitions of the region. Because if a student would then say, I want to get the area of this one here if I integrate with respect to x, you can see that now if you draw a vertical line through this particular region of the part of the region, it would enter the region through the parabola, exit through the straight line. Even here through the parabola, exit through the straight line. Here it will enter through this horizontal line, exit through that. So in principle, if you integrate respect to x, just to find the area 1 of the top, you'd have to partition to a small area here, which is going to have a bottom curve, parabola, and upper curve, the straight line when you draw a vertical line. And the same is going to apply here. When you draw a vertical line, it's going to pass through the parabola, exit through the straight line. And also here, it's going to pass through the straight line and exit through the straight line there. So you need like 3 areas. But now also the bottom here, he's going to enter through this part of the parabola and exit through that part of this parabola and exit through that. So in each case, therefore, if you integrate with respect to x, you'd see that it would be a bit more involving. Obviously, but obviously you could use symmetry. You could use symmetry and say that surely this looks the same as this. So you can just find the area of this part and multiply by 2. You know, the answer is going to be the same because this is symmetric. This parabola is symmetrical about the y-axis. So you can also just integrate this part and also just multiply by 2. You would actually be able to get the same answer and the same value of C. Any questions? So that was number 3. Move on. Right. Obviously, you indicated that we as well need to do number 6. Okay, these are the areas, the volumes by disks perpendicular to the x-axis, the volumes of the solid. Please, you need to revise your things, your hyperbolic functions, the derivative of the sine, cosine, but the hyperbolic functions as well. Right. So now the method of the cylindrical shells, volume by cylindrical shells. Okay, I want us to recap on that before we move on. The volume by the cylindrical shells, you can see that about the y-axis. Right, so then the volume V of the solid of revolution that is generated by revolving the region R about the y-axis is given by, about the y-axis becomes 2 pi x. About the y-axis becomes 2 pi x, f of x, dx. About the y-axis becomes dx for the cylindrical shells. Y-axis, but it's dx, all right? And then you have exactly that. Okay, we move on. We move on. So we are moving to number 6. Calculate the volume of the solid that results when the region enclosed by the given curves is revolved about the x-axis. Let us check this one out. And then we shall decide if to use the method of the shells or the disk or the washer method. Right, so at this point, you'd have that you have the 6a. Okay, now let's just picture what we're dealing with here. So the x equals the square root of y is what? Is this kind of the graph. Yeah, it is the same as x squared equals y. So it is just going to be exactly this here. Okay, we pause to reason this out. Okay, let us pause this. So you have exactly x equals the square root of y. Okay, your right. So it is exactly that part. So now, obviously, this one is a straight line. So this will be the graph of x equals the square root of y. You can square both sides, getting x squared equals y. So it's a standard graph that is x squared equals y, but it is only on the x greater equal to 0 part. This is our y-axis and this is our x. And then you have x is equal to y out of 4. Y equals 4x. And therefore this is y equals 4x. Take a look. And then now I have this. So we need to find the volume of the solid that results when the region enclosed by the given curves is revolved about the x-axis. So you decide to revolve it about the x-axis like this. Right, revolving about the x-axis, so you actually obviously have a couple of observations to make. A couple of things therefore become very important. Are you having any gap? So the easiest method to use here is actually most certainly the washer method. Right. So, which means the volume becomes the integral of the following. Right, you decide to integrate from this to that because it's about the x-axis. Now, I want us to find the points of intersection of this. So, if these are the two graphs, what is the point of intersection? So x is y over 4, and then x is the square root of y. Y out of 4. 4 the square root of y, 16y is y squared. Y, which is y minus 16. Y minus 16. Y is 0, y is 16. Okay? Right, so, but now this happens when you put the y equals 16 here, you'd have that x is 4 and then x is 0. So this intersected the origin, but also they intersect when x equals 4 and y equals 16. So to find the volume of this, we proceed as follows. Right, we proceed as follows. Right, we proceed as follows. Now, if you actually are able to do this one here, you therefore realize that by the washer method, you use a single pi. You use a single pi. So that we have pi, then you integrate, because now you want to integrate with respect to x. So you integrate from a to b, which you can put straight away the x limits of integration. Right, so the x limits of integration, you'll integrate from what to what? From 0 to 4. So there's going to be something we call the outer radius. The outer radius, because if you look at this here, the distance here is going to be the outer radius, which is going to be the straight line squared minus the inner radius, which is going to be exactly the x squared. In principle, what then happens is that if you integrate with respect to this particular axis, you'll find the outer radius. The outer radius is going to be exactly 4x minus 0 squared. Right. And then you continue to analyze that precisely. And then you subtract also the inner radius. The inner radius becomes x squared minus the y, their component squared dx, giving us the volume. Pi, the integral from 0 to 4. You square them for x, you get 16x squared, x to the 4th power, dx, so that the volume is pi, and then you have 16x cubed out of 3, x to the 5th power out of 5, from 0 to 4. which is pi. Okay, you put the 4, which is 16. Then you have 4 cubed divided by 3, and then you have 4 to the 5th power out of 5. Okay, you can deal with this. Let us use a calculator to save time. Right, let's use a calculator to save ourselves a bit of time. Okay, we might take a break, I think, very soon, and then we shall return. Okay, let's just check what you'll advise, please. So you're going to have, for example, let's just deal with the numbers. So you're 16 times 4 cubed divided by 3 minus 4 to the 5th power divided by 5. And then you have, okay, that's fine. I'm going to check your message, your thing, your chat. So it's 2048 pi out of 15. So indeed, we got that the volume is 2048 pi out of 15 cubic units or units cubed. Okay, I'm checking your message. I'm checking your message. Okay, that's fine. So that then in the end, I'm going to make this recording available so that indeed here we got that the volume is exactly that one. But the method is going to be the same even when you do the part B. Right.
So,
Yes.
so in the part B here,
Yes.
how do I to draw this graph?
Yes, how to draw the graph. Okay, let us do it. Let us do it to save to make sure that you are sure. Okay, right. So in part B, we're gonna do likewise. So we're gonna just draw a rough sketch to see which one is the upper curve and which one is the lower curve, but also using the disk, the washer method, because there's a little bit of a gap. Right. So now you would have to draw the graph of this. What is the graph of this here? Right. So the graph of this is actually the graph of, you can square both sides to see the graph. You have y squared, for example. I mean, you need to think it's not a usual graph, this one. Right, so you have this. Okay, this will still be very tricky to see what kind of graph this would be. But now you need to use your standard intuition. I'm going to mention that because some of these graphs, you don't need to spend a lot of time drawing the graph, but you just need a rough idea so that you're able to see which one is the upper curve, which one is the lower curve. You can't spend the whole time drawing the graph because it's not the business of the module, the drawing graphs. In this module, we want to see the volumes and areas. So now the kind of graph that you have, here it's going to be what? For instance, when x is 0, right? So you'd have this particular graph, but when x is 0, okay, you have 1 over the square root of 4 plus x squared. When x is 0, y is 1 over the square root of 4, which is 1/2. Right. So as a consequence, you would have exactly the following. Yeah, so it's going to be exactly 1/2. And then now this graph is going to be such that whenever x begins to increase, then the graph is going to slow down like this. And also the graph is going to sort of slow down like that. So this is a sort of graph you're going to have. Right. So, but obviously just a question of an idea. When x is 0, then you have 1/2. But then you can see that for the graph, as x increases, then the denominator becomes very small, or the denominator becomes very large, making the function very small. Now, as a consequence, then what you're going to have is that it's going to be having a y-intercept of 5. So this one is sort of the y-intercept. And from school, the idea of the y-intercept, because you must resort to that, happens when x is 0. When x is 0, then you get y equals 1/2. Right, when y is 0, then you can be able to get the x there. Okay, so we can see, therefore, that the range of this function is, the range of this function, for instance, would be, right, the range would be 0, y, 1/2, like that. Anyway, never mind that. And then they're going to be horizontal asymptotes, which is going to be, this is going to be sort of the asymptote, and then you have, okay. But now there's more information. This is just the graph of y equals 1 over the square root of that. And then you just plug in the rest of the stuff there. So if this is the case, then you have y equals 1 over the square root of 4 plus x squared. Okay, then x is minus 2, and then x is 2. X is 2, and then x is minus 2. X is minus 2, then x is 2. Minus 2, 2, and then y equals 0. It's this one, so you have exactly this region. Right, so this is the region that looks like a building that is a gable. It looks like a building structure that is a gable, sort of, some roof. Anyhow, right, so now it's easy to find the area. But what method would you use? Right, because you revolve about the x-axis, the easiest method to use here is the disk method. Because this one is not going to be a washer when you rotate about the x-axis. It's not going to be a washer, because washer means there is a small gap. If there was a gap here, just that this is elevated, there's some space that is open, we're going to, when you rotate this, it's just going to leave a hole in the middle, forming a washer. But now we're going to use the disk method. Right, so now using the disk method, because this whole thing, if you rotate it, is just sitting on the x-axis. This area that's sitting on the x-axis become require the disk method. Or now you can also use the method of the shells. Right, we can also, the answer is going to be the same. So the method of the shells become very, very versatile. By and large, the method of the shells work all the time. If you revolve these about the x-axis, you can be able to find the outer shell and then also the inner shell. Okay, right. Oh, of course, the method of the shells requires that this whole thing, if you revolve it about this, it forms a shell. And if it forms a shell, okay, we're going to get to that. But let me first do it with the most direct method, because it's sitting on the x-axis, then it forms a disk. So that the area can use some small disks. And then now you integrate, because it's about the x-axis, like we saw before. What is the x value here? The x value is minus 2 here, and the x value is 2 there. So integrate from minus 2 to 2. The upper curve, here you'd have to find the pi, and then you'd have to find the outer radius. Right, so now if you integrate here, you have to find the outer radius. The outer radius is going to be obtained from a point here. So now this is going to be a disk. Disk means, therefore, you rotate about this axis, and now you would have to find the outer radius. The outer radius is going to be exactly the y equals this. And then you would have the 4 plus x squared. And then what is y? So you do y minus y here. Y here is the graph, which is this, and then y here is 0. So that is going to be a radius for us, because the distance from here to there. It's a radius because the disk it's going to run like this. So half of that distance is the radius, and also is the same magnitude as this. Minus, so that is the thing. And then minus the, okay, they love the method of the cylindrical shells in your class. So yeah, we need to discuss that a little bit before you go. Right, so you have that. Now, if you do that, then this is okay. So you don't need other terms here, because it's just the same graph right through at the top, and then the same graph at the bottom. So you have found the radius of any disk that can be drawn, and therefore you can close and put a dx like this. What is the area? The area is from minus 2 to 2, because it's minus 2 to 2 on the other side. Pi, and then you square this one. The 0 does not affect anything, and therefore you have 4 plus x squared. Right, that will exactly be 4 plus x squared. Okay, and then if you square this, the square root goes away, you have a dx. Right, so now this is nice and easy. Then you need to find the integral of this. Okay, the integral of this is a very interesting one. We're back to some of the techniques of integration, because integrate these, you can let u be 10, but yeah, not so important, because you already know that you can write pi and then pull out the 4 from the denominator. Pull out the 4 from the denominator, you have minus 2 to 2, then you have 1 over. Pulling out the 4 would be 1 plus x squared over 4. You can write it as x out of 2, then you have the dx like that. Okay. Yeah, we just need to do this particular integral here. Okay, I put out the 4 so that this thing can resemble the formula of 1 plus x squared dx, because we know this integral is arctan of x. Right. So we're good.
So on that
Yes.
note, sorry, on that note, where I said okay, wait, here where you pulled out the 4. So every time it has to be a constant one.
Yeah, the constant must be the number 1. Must be the number 1. So that it becomes arctan of that. But again, obviously, you see, pulling out the 4 affects there's going to be a 4 in the denominator that's going to sit under the x. So you need to let, because this one is not a simple variable, it must be like one variable. So let u be x out of 2, so that du is 1/2 dx. Okay, so that now the area becomes pi over 4, the integral 1 over 1 plus u squared. What is dx? It's 2 du. Right, so you integrate, then it is minus 1 to 1, pi out of 4, then and then there's a 2 here. You see now, because of the x over 2, there's going to be a 2 that's going to come from the derivative. So these 2 now, it's going to multiply things out. It's going to actually have an effect on the answer. But in sense, it's going to be like, this is pi over 4, so it's going to be 2 pi out of 4. Then now this is exactly of the form 1 plus 1, 1 over 1 plus the u squared, which is arctan. Arctan u, right? And then from minus 1 to 1. Always change your limits of integration when you change the variable. It makes life easy. It makes sure you get the correct answer. So this is pi out of 2. Then you put the 1, which is arctan 1 minus arctan minus 1. So this is the answer we're getting. What is the area? Pi out of 2. The arctan pi, yeah, arctan 1. Okay, it's pi over 4. And this is negative, negative. The negative goes out through the 10 function, so that negative by negative, it's a plus pi over 4. Okay? So doing this one is pi out of 2. Okay, here we use the washer method, rather the disk method. Before we used the washer method because there was a gap. So the pi over 4 becomes pi over 2. Then we have pi times pi becomes exactly pi squared. 2 by 2 becomes a 4. Exactly the answer they got. So in other words, by using the disk method, how did we know to use the disk method? The disk method always works if this is sitting on a given axis of rotation. If this is sitting on the x-axis, or it can even be sitting on the y-axis. But if it sits on the y-axis, then integrate with respect to y. If it sits on the x-axis, you integrate with respect to x. But I think that I would be interested in speaking about also, something very important here as a conclusion, what you call the shell method. The method of the cylindrical shells. The method of cylindrical shells. Right. So now I think I'll conclude by that one. Right. So now if you look at just one second, I want to also discuss this particular problem in view of what you call the method of the cylindrical shell. Cylindrical shells. Right. So the method of cylindrical shells now would actually constitute the formation of shells in this particular case. And let us look at it together. In case we revolve this about the x-axis, you need to form a shell, but the answer is going to be the same. Okay, you need to form a couple of cylindrical shells. Let's take a look. So now, using the method, in other words, the volume by cylindrical shells, because they love this, would have had a chance to look at the washer method, the disk method, and also the method of cylindrical shells, which are basically all the three methods we use for the volume. Right, so in this case, what is the area of this? You just need to say when x is 0, find the intercept of the graph, then to really claim that you can always be able to know how the graph is going to look like. So we saw that indeed this graph is going to form a dome like this, y and then x. But also this graph is going to have a couple of roots. X equals -2, right? X equals -2. And also this x equals 2. So this is what we have. Okay? I want us to discuss the method of the cylindrical shells. So the x equals -2 and x equals 2, but also there is y equals 0, which is the x-axis. And we want to just use a different method, the method of cylindrical shells, to get the answer a little bit differently. Now, what is the method of the cylindrical shells? There's something we call the volume. Right, the volume, therefore, for instance, you decide to integrate from A to B, right, and then now, this is given by the following. There's something we call the area. The area of the shell, just going back to the basics a little bit here, the area of the shell's mantle or crust, and then you put here, for instance, your dy. Okay, this is a method of cylindrical shells. It has the dy for the x-axis. Right, so now you would integrate, for example, here with respect to your y. Right, so obviously you'd remember that this is exactly 1/2. So if you integrate with respect to 1/2, you'd actually realize that with respect to the y, you integrate from 0 to 1/2. And then now let us form the shells here. So I'm going to form the shells in green color. So for instance, a shell can be formed. Right. Now, what would you observe here about these particular shells? What is the best way to form the shells? So for instance, if you form a horizontal shell like that, you would actually be in a position to see that you would revolve this way, you would revolve that way. So it's gonna run like this, or it's okay. Okay, but now the couple of things you need to consider when you do the shells. What would be the area of the shell's mantle? Right, so the area is gonna be like 2 pi y multiplied by the height, dy, the volume. 0 to 1/2, 2 pi y. What is y? Obviously, our y here is nothing other than the y value here. Right, and the y value here is exactly 1 over the square root of 4 plus this one, 4 plus x squared. Okay. Okay, now take note of the fact that if you use the revolution about the x-axis and it becomes exactly this, but you would have to make the following change in just a little bit of time. Okay, you have to make the following change. So you need to put an X here. You need to put an X there. Okay, because okay, let us analyze the shell here. Okay, so the X, there can be some X value here, and there's going to be some X value there. So now this would be, for instance, the height. So the height is going to be in terms of the axis, and then the 2 pi r, the 2 pi r. So in other words, if you're able to see that at this point, what would the radius be? So now if this goes up high like this and goes up to y, then you'd have like your y out of 2, and that is going to give you the radius. So in other words, this is going to be 2 pi r h. 2 pi the radius. So if the disk is lying like this, its radius is going to be y out of 2. That is fine. So if its radius is y out of 2, then you're going to have exactly this out of 2. And then the height is going to, okay, it doesn't really matter what you do. But now let us put the variables accordingly. Right. But before that, I think I would want to show something. There's a result I want to show, then so that we can actually do everything in order. Okay, just 1 second. I'll show you another result before this. Okay, because I have cited this formula. Okay, right. So the formula we're talking about is exactly this one here. Right. So now, obviously, then the volume of the solid of revolution that is generated by revolving the region R about the y-axis is this. Okay, but I want us to take note of the fact that if it is by the y-axis, look at the variables. By the y-axis, you have the two variables that interplay. So about the y-axis, you realize that you integrate from A to B like that. And it is where x is A and x is B. So it's about the y-axis. About the y-axis, you put a dx. And it becomes from A to B, and you have 2 pi. Because it's about the y-axis, you put dx, and you have x, and then you have f of x there. Okay, so simultaneously, I want us to look at this carefully because I want us to use exactly this result as it is, because it's actually the result from the textbook. But yeah, I would like us to just recap on this very briefly as we move on. Okay, let us adopt exactly this particular notation and use this notation in our problem here. Okay, so now in our problem here, the couple of ways you can obviously look at that, because if it is about the x-axis, then you need to change, as we said. About the x-axis, you need a dy. You have your limits of integration there. Right, and about the x-axis, you need 2 pi y. Right, like that. And here you would have your x. Right, that's fine. So in other words, you would have 2 pi y, then you have what? Then you have x, then you have what? Then you have exactly dy, like that. And this would be about the x-axis. Okay, very good. So the dy, everything is in order. Okay, let us just compute this. So it's 0 to 1/2. Okay, so now you have the 2 pi y. What would your y be at this particular point? Right, so you have 2 pi y, and then what is your x? That's what you need. Because you already have a dy, so you need to replace the x by using this particular formula. Y is equal to, according to the given function, is 4 plus x squared. You square both sides, you get that? And then it is 1 over y squared, which is 4 plus x squared. Right? You need to get your x. So x is going to have like two sides, obviously. There are going to be two of them. And that is going to give you the height. Okay. So it's going to be 1 over that. Just do it. It's going to be 1 over y squared minus 4 equals x squared. X plus or minus 1 over y squared minus 4. Okay. So if these are the possible like x values that you can be able to get for a corresponding y. Right, let us write them down because we're going to use them. Okay, yeah, so this method, you need to look at both x-axis and the y-axis. Please, you need to remember it. So that you have plus or minus, because they love the shell method in your material. So I'm sure that it is there in the exam. It might not be surprising that it's pretty much the most dominant in the questions. Right, so you have exactly that. So now, if this is the case, let us remove this rough work. We're just making x a subject for the height. Right, so we're good. Okay, let us see. Okay, let's continue, please. Okay, we have 2 pi y, then what is x? X is this one. But obviously, if ever x, whatever x is at any of the points, okay. Okay, never mind that. So whatever x is, there's going to be a negative x there, positive x there, but what is the height overall? So we expect the height to be double. Okay, you can look at it, it is symmetrical, this, but you can look at it as double 1 over y squared minus 4 dy, like this. Okay. Right. So now let's check this out. So we're going to have the following. Yeah, we're in business now. V equals. Okay, now you have the 2 pi y with the 2. Okay, then you're going to have what? You're going to have 4 pi. You're going to have 4 pi, the integral from 0 to 1/2. 4 pi, and then you have y. 4 pi, then there is a y. Then you have the square root of, what did you get the square root to be? Is the square root of 1 over y squared minus 4. Okay, and then dy. Like this. Okay, let us find the integral of this, which is 4 pi. Okay, we do the thing we are used to. 0 to 1/2, and then we have y. Okay, pull out the 1 over y squared. Always, if there's a fraction, you pull out the y over y squared. Pull out the fraction like that. But if you pull out the 1 over y squared here, you're left with 1, and then you have minus 4y squared. So that when you multiply, okay, this is very similar to the arc length calculations. When you multiply by the 1 over y squared, then this is going to be like a minus 4, and this is going to be 1 over y squared. Okay, each one has a square root, so you can just multiply the insides of this. 4 pi. Okay, the integral from 0 to 1/2, and then this is y, 1 over y. Then you have the integral of this, 4y squared, dy. The volume. Okay, the pi cancels out with 4 pi. By the y cancels out, giving us 0 to 1/2, and then you have 1 minus 4y squared, dy. Okay. Okay, you see the method of the cylindrical shells, it's working, but it's going to be a little bit hectic because of the nature of the integral. Okay, because this integral here is gonna, we're gonna do it, but the answer is gonna be the same. But you can see that the easiest method, because this was sitting on the x-axis, the easiest method was just to use the disk method. But I mean, all the methods work. Right, so now this one, you're gonna use a trigonometric substitution because it's like it's 1 minus sine squared. So 1 minus sine squared, then you can use that and say let the, okay, because you can write it like this. Okay, I'm just gonna conclude here because obviously in the exam you might not even have the thing, so you might not even have the formula, the table of integrals, so that you can know what the integral of this is gonna be. But it is 1 minus 2y. Then you square these with the dy, so you would have to let u be 2y. Okay, yeah, it's okay. Right, let u be 2y, and then you're gonna have the derivative. Du is 2 dy. Okay, this method is not, yeah, the easiest one was use the disk method because sitting on the given axis. But okay, 0 to, okay, you integrate from, now this one is y to the new variable. Y to the new variable is u. Y is from 0 to 1/2. U is from what? U is 2y, which is 0. 2 by that is 1. So now this is the volume for pi, the integral 0 to 1, the square root 1 minus u squared. What is dy? Du out of 2. 2 pi, the integral from 0 to 1, 1 minus u squared du. 2 pi, 0 to 1, the square root 1 minus u squared du. Okay, I'm just using the method of the cylindrical shells, please. Du. Okay, now if you get to this point, you still need to find this integral, and you can't. So what you can do is to let u be the sine of. Okay, let's check. Yeah, let u be the sine of theta, because it's 1 minus sine squared, so that du becomes cosine theta d theta. Okay, the answers are the same in the end; they will be the same, but you're going to show that it works. So that you change now the variable from u to theta. U is from 0 to 1, and when u is 0, and then here you have 0, and when 1 here, you have pi over 2 radians. Volume is 2 pi, the integral 0 to pi over 2 radians. 1 minus, the u is sine squared theta. What is du? Du is cosine theta d theta. The integral of 2 pi from 0 to pi over 2 radians. The 1 minus sine squared is cosine squared. The square root of cosine squared becomes what? Becomes just cosine between 0 and pi over 2, so that cosine by cosine is cosine squared theta d theta. 2 pi radians. The integral from 0 to pi over 2. What is this? Cosine squared, okay, from high school. Cosine double angle. Cosine 2 theta, can expand that one. Expand it. Double angle formula. Cosine 2 theta is 2 cosine squared theta minus 1. Okay, then it becomes exactly cosine 2 theta plus 1 out of 2. So cosine squared becomes if you want to integrate cosine squared, you integrate cosine 2 theta plus 1 out of 2 using the high school identity, and then you have exactly a d theta. Let us do this. So then the volume is given by 2 pi, but there's out of 2 there, and you integrate the cosine theta. The integral of cosine theta becomes 1/2 sine 2 theta plus theta. You integrate from 0 to pi over 2 radians. Pi, then you have 1/2 the side of the following.
Hello.
Yes, please.
Hello.
Your time is up.
Is it also possible to use the is it also possible to use the 1/2
Yes, yes, it's possible.
property identity or what?
Yes, it's also possible. Yeah,
Yeah.
yeah, it's also possible.
Yes, okay.
Yeah, okay, great. So now, just want to see, because we just want to compare the methods here, the cylindrical shell method, because you've already got the answer. So now this one is pi over 2, and there's another pi over 2. What is the sign? Pi over 2 cancels pi over 2. The sign of pi is 0. So this is going to be like, have a 0. Could I have a 0, a 0, a 0? Okay, remember that I need to write the things properly. So this half is outside like this. So this half is outside like this. So that in the end there's pi over 2 here, but this half you can bring it here. And the 2 cancels, giving us sine pi, which is 0, and then you have pi over 2. And this is, there it is, pi squared over 4 cubic units. Okay, I know. We went through a lot. Okay, you see, we went through the trig substitutions and things with the shell volume by cylindrical shells, and it was okay. But we realized that once again, the cylindrical shells, you can form them. And here's an example of a shell that you formed. And to form the shell, sometimes you go back to the basics and say, it is area of the shell's mantle, the exterior dy. And what is the area? So you can cut this open like, and then have the 2 pi radius. Okay, as much as write 2 pi y, it's 2 pi radius height. Okay, which it becomes, the 2 pi r becomes the circumference of the circle cross-sectional surface area multiplied by the height, because this thing can be cut open like this. And it becomes 2 pi r h. I'm trying to make sure that you know the basics a little bit so that you don't get confused when you're doing these cylindrical shells. They love it. There are too many hard questions in this. So that in the end, then you say area of the shell's mantle, it's 2 pi radius. What would the radius be? If the shell is like this, the radius is, okay, this is the circular cross section, and you go to the y, then the radius is half y. Okay, so this is the case. So it's 2 pi. Now you then say it is 2 pi r, and then you come and then say it is 2 pi y multiplied by the height. Right, so what then are you going to have here? What would the height be? The height is going to be exactly a 2x. 2x. Right, 2x. And then now, because it's minus x, and then it's 2x. Right? So, okay, if it is dy, then it's 2 pi y x. X is the height. 2 pi y dy x is the height. So you have like negative and positive x. Right, so the x, it was, we made x a subject. You got x is plus or minus 1 over the y squared minus that. And then you got exactly this here.
Sorry, can you please elaborate on the 2x part?
Yeah, the 2x part, because now when you find a random cylindrical shell would be actually will have an x that is negative on the negative side, but it also have an x on the positive side. But they are like the same size because it's symmetrical, these. So that obviously to find the height, you'd have to take this distance and that distance. So it's x and x is 2x. But if x is plus or minus this, so you'd have to take the square root 2 of the square roots, because there's an x in this direction, the x, and so it's 2 of the square root. That's why we have 2 of the square root. you know. But note that when you are doing this calculation, you need to always use the fact that it's 2 pi y dy. Right, because why is this? The volume formula, for instance, the one that we did in the textbook is A to B 2 pi x f of x dx. And this one would be the volume about the y-axis for the cylindrical shells. Okay, it will be a volume about the y-axis. So if you say about the y-axis, it becomes dx. It sounds like the opposite, because about the y-axis, then it's like counterintuitive because it's going to be dx, then 2 pi x, yet it's about the y-axis, and you only have the y appearing there. And the limits would be a to b. Simultaneously now, here we change because the examiner said it's about the x-axis. So about the x-axis now, you put dy 2 pi y, then you just put the height. What is the height? Then the height is going to be like an x that is on the negative x, so it's like 2x's. But x is the square root of this, it's double of this, dy. Okay, so you have this. Okay, yeah? Okay, good. Right. So now, Amas, thank you so much for joining us. Now we're just discussing the method of cylindrical shells. I'm sure that we shall have more discussions moving forward, but it was a way of making sure that, yeah, we don't stress so much. So, okay, I'm going to send the recording in the next couple of minutes. Right. Amas, thank you for joining us. It was awesome having this discussion. Until next time, take care and goodbye. Goodbye.